Hello and welcome to World of Warbirds. I'm Brian Pierce. Please sign up at my Patreon to get episodes earlier, bonuses, to have a say on future content, and to interact with me and other Warbirders directly. But mainly you'll have the satisfaction of helping keep this podcast going. You can also toss me a tip via PayPal at WOWB17, or even just drop me a review. Thank you for your support. Now on to the show. Hello, Warbirders. Okay, so this one was suggested for the list quite a long time ago by Leon from Patreon. And so I'm happy to finally present it. The 335 has always intrigued me, and so I'm quite excited to get at it. Firstly, I'll apologize right now for German language pronunciations. Although I like to include original German terms for, spice and authenticity, I know I struggle with saying them for two reasons. Firstly, languages are just not my thing. And living here in Montreal, I don't often hear many German language native speakers. Alright, well, enough apologies, so let's dive in. Before we get to the aircraft itself, I want to address the company name, which I've always wondered about. I've always pronounced it Dornier, but if I saw it as a person's name here in the French-speaking part of Canada where I live, I would pronounce it Dornier, because it sure looks French. I was emailing back and forth with John Spooner, a listener from Germany with a German wife. She says it's more like the French, so I'm going with that. Well, it is French. The founder's full name was very French. Claude Honoré Désiré Dornier. And he was born in May 1884 to a French dad and a German mum. During his schooling, science was his main interest, and he later relocated to Munich, where he graduated from the Technical University in 1907. He did non-aeronautical engineering, so boring, until 1910, when he was employed by Luftschiffbau Zeppelin in Friedrichshafen. He caught Count Ferdinand von Zeppelin's eye and was soon tapped for special projects and eventually specialized in stress skin, all-metal monocoque aircraft designs. I don't think we've ever looked at the aeronautical term monocoque before, and so I guess we should. A monocoque aircraft design is a structural approach where the outer skin of the aircraft carries most or all of the load, rather than relying on an internal framework of ribs, spars, or trusses to bear all the stresses. The word comes from French, mono, single, and coque, shell. Think of it like an eggshell. The thin shell itself provides all the strength and rigidity without internal support. Most early aircraft were not like this. They were tubes or wooden frames covered with a fabric skin, with obviously the fabric not providing much support. A pure monocoque design wouldn't need any framing at all, and the entire load would be supported by the skin. But in most cases, aircraft are semi-monocoque, with the load being shared by both framing and skin. Well, Claude Dornier was one of the first to work on these, including the Zeppelin Lindau D1, which was a single-seat, all-metal, stress skin, semi-monocoque biplane fighter. It was too late to see service in World War I. He had founded his own company by this time, and in the interwar years they focused mainly on flying boats. But they also built land planes too. And these had to be built outside of Germany to get around the whole Treaty of Versailles thing. You've probably seen the Val, meaning whale, and the Superval, and the Dornier X, or maybe it's Dornier 10 flying boats. At the time, the Dornier 10 was the largest flying boat in the world. It was powered by 12 Siemens-built Bristol Jupiter radial engines in tandem push-pull configuration mountings set on pylons on top of the wing. They needed lots because they only produced 524 horsepower each, but it sure looks strange with this forest of engines on top. But it sure must have been a thrill to shove those 12 throttles forward, though. Okay, I'm going to skip forward a bit now because I don't want to just mention and gloss over the other Dornier products that deserve their own dedicated episodes, such as the Dornier DO-17, Fliegender Bleistift, or Flying Pencil Bomber. But we're really here for the 335, right? And the more that I looked into it, the more that I saw that this story is about Claude Dornier's side obsession with aircraft with alternate engine configurations. Remember the Val, the Super Val, and the Dornier 10 flying boats that I mentioned before? They were all powered by tandem engines. He also had a thing for pusher engines, and he wasn't the only one. My whole series called Doomed Fledglings was about American experimental aircraft trying out this concept, with the XP-55 Ascender, Vultee XP-54 Swoos Goose, and the Northrop XP-56 Black Bullet. Give those a listen if you haven't already. The pusher configuration wasn't as radical as you might think. The OG airplane, the Wright Flyer, was a pusher, and there are actually lots of advantages in having the engine at the back. The first is performance. Without prop wash being flung over the wings, fuselage, and empennage, you have a clean and undisturbed air moving over these surfaces. There's no rotating prop wash hitting the tail fin to deal with, so not so much rudder input is needed on takeoff. Visibility is improved without the engine and the whirling prop in front, and you can easily put more and concentrated armament in the nose, where the bullets and cannon shells will be coming straight out forward, without having to deal with shooting around or through a propeller arc. Finally, pushers can be safer for the pilot, as all that hot metal and fuel and oil and burning stuff is located behind him. With an engine fire, rather than the airstream blowing all the fire in his face, it'll actually be burning away and behind him. So, back in 1937, Dornier started an experiment that would eventually lead to the 335. The experiment was the Göppingen GO-9. The GO-9 was essentially a 40% scale model of the Dornier DO-17's fuselage and wings, but without the twin-engine nacelles. Its wooden airframe featured a retractable tricycle undercarriage, and power came from a fuselage-mounted Hirth HM60, an inverted air-cooled four-cylinder inline engine positioned in the center of the fuselage near where the wing roots attached and driving the rear-mounted four-blade propeller via a shaft. The engine had to be this far forward in order to avoid tail heaviness. You could think of it as similar to the Bell P-39 Airacobra and P-63 King Cobra, except that the shaft went back to a prop behind the tail instead of forward to a prop in the nose. But the prop way back there caused its own problems. A tail strike is a not unheard of thing. Yours truly may or may not have dragged a tail or two in his time. And it can be bad, but usually isn't terrible, as long as the strike isn't too hard. But a prop strike of any kind is bad. There's just too much spinning power there for the strike to not cause catastrophic damage to the prop itself and all the way back into the engine's innards. So Dornier's solution was this experimental aircraft's most distinctive characteristic, which was its cruciform tail unit, with four surfaces, including a large ventral fin and rudder that match the size of the dorsal surface. So imagine an equal-sized fin as the one pointing up, but pointing down. The ventral fin was fitted with a small auxiliary tail wheel at its tip, which protected the rear-mounted four-blade propeller from striking the ground during takeoff and landing. The experiment progressed slowly, but eventually the Go-9 was towed aloft in June 1941, and it flew. Later on, powered tests validated Dornier's ideas. With the concept proven, he began work on his tandem-powered beast, which is the subject of today's show. The tandem engine configuration offered some unique advantages. If he could successfully mount one engine in the nose and another in the rear fuselage, Dornier would achieve the power of a twin-engine aircraft while keeping the aerodynamic drag very close to that of a single-engine design, and the speed and climb performance promised to be amazing. There was another advantage. Conventional twins with the engines on the wings are great as long as both engines keep functioning. As soon as one quits, you don't just have the deficit of half the power, you have the feathered, or even worse, windmilling prop on the dead engine adding to the drag. And with the isometric, meaning unequal, pull of the thrust on one wing and the drag on the other, the aircraft becomes very difficult to control, and in some cases is actually uncontrollable. With the tandem engine configuration, this isn't a problem. If one engine fails, since both engines are aligned along the center line, there's a power loss, but no isometric thrust and much less drag. Dornier got the chance to try out his ideas when the RLM published a requirement for a single-seat Schnellbomber-like high-speed bomber intruder. Schnellbomber literally means fast bomber and relies on speed to avoid enemy fighters rather than needing defensive armament and armor. Think of the de Havilland Mosquito, which, although British, is kind of the perfect example of a Schnellbomber. In May 1942, Dornier submitted a design that would be able to haul a 1,000 kilogram, that's 2,200 pound, bomb load. The design was built around the two engines, both Daimler-Benz DB603s, which were liquid-cooled V12s producing around 1,750 horsepower each. The nose-mounted one was pretty conventional, just like in the ME-109. Just behind that firewall was the cockpit, and then behind that was a big fuselage fuel tank. Here's where things get unconventional. Just aft of the fuel tank was the second DB603, pointed backwards and turning a 3-meter, that's roughly 10 feet long shaft, back beyond the tail to the rear prop. This shaft was supported by multiple bearings along the fuselage to keep it aligned and reduce vibration. You can imagine how even a little flexing or imbalance could have caused destructive resonance at high RPM. Cooling, lubrication, and reliability of this drive shaft were among the more complex engineering challenges of the design, but Dornier's team managed to make it work. The mid-mounted wing was of relatively modest span and featured straight tapering lines. Its design kept the aircraft compact, especially compared with other comparable twins like the de Havilland Mosquito. The 335 was about 6 feet longer in length, but had 9 feet less in wingspan. Additional fuel tanks were fitted in the inner wings, between the fuselage and the main landing gear bays to carry a total of 1,230 liters, that's 320 US gallons. Although fittings were provided for jettisonable drop tanks mounted under the wings to increase range for longer missions. The internal weapons bay was located beneath the cockpit floor between the main landing gear wells. This bomb bay could carry a single 500 kilogram or 1,100 pound bomb or two smaller 250 kilogram bombs mounted side by side. The bay doors were flush fitting helping to preserve the aircraft's clean aerodynamics and very high top speed. For guns, the new fighter had a 30mm motor cannon 103 embedded in the forward Daimler-Benz DB603 engine, firing through the nose propeller hub with a 70-round supply, plus two 20mm cowl-mounted synchronized autocannon with 200 rounds per gun. This setup gave the DO-335 a powerful centerline concentration of fire, with the 30mm round being especially effective against heavy bombers. Just like the experimental Go-9, the 335's tail was a cruciform layout, with a large ventral fin and rudder beneath the fuselage to balance the tall vertical fin above. This was necessary to counteract the effects of the rear propeller slipstream and to keep the design aerodynamically stable. The ventral fin also doubled as ground protection for the pusher propeller. Oh, that pusher prop. Can you think of any problems that it would present being back there? Yes. Yeah, it would essentially be a slicer-dicer, making mincemeat out of any pilot trying to bail out of the 335. Even cutting the engine power left the prop windmilling at lethal speeds. Features would have to be built in to prevent making pilot burger. So, a key design safeguard was an explosive bolt ejection system. Both the rear propeller and the upper vertical fin could be blown clear away in an emergency to give the pilot a safe bailout path. As this whole option and procedure is so new for our era, I'm going to give you a summary of what the pilot's step-by-step procedure would be to bail out using the explosive bolt system and the ejection seat, which was designed and built by Heinkel. Number 1. First, stabilize the aircraft if possible. Throttles to idle. Keep the nose near the horizon. Tighten shoulder and lap belts. Keep the harness latched until the seat fires. Number 2. Pull the canopy release so it blows clear using the cartridge jettison system. Verify that you've got open sky overhead. Number 3. Lift the safety cover and arm the explosive bolt circuit, which was a guarded switch, which you can understand why. Number 4. Pull the rear prop emergency jettison handle. Explosive bolts sever the hub and the pusher prop departs rearward. Meat grinder removed. Number 5. Pull the upper fin rudder jettison handle, and charges below the dorsal vertical tail free to open a clear upward path. Number 6. Adopt the posture. Head back, chin tucked, elbows in, heels on the rudder pedals and footrests. Grab the ejection handle between the legs in Heinkel seats and pull sharply. The cartridge fires and the seat launches you on a clear vertical track. Number 7. Once clear of the aircraft and in stable air, release the seat and then pull the parachute ripcord. The system was designed so the prop and dorsal fin were to be jettisoned before the seat goes, either by pilot action, like I just read, in steps, or via interlocks in later designs. If altitude and time were critically low, pilots were trained to prioritize prop fin jettison and immediately eject, rather than extensive aircraft cleanup. Keeping the harness tight until the seat fires, and never to try to stand up and jump. They were to use the ejection seat. In the middle of designing all this in autumn 1942, Dornier was told that the DO-335 Schnellbomber was no longer required, and instead a multi-role fighter was requested. These modifications delayed the prototype delivery. The DO-335's first prototype finally flew on the 26th of October 1943. The landing gear was found to be weak, There were problems with the main gear doors, and they were left off for version 1's test flight. The 335 V1 made 27 flights, flown by 3 different pilots. 2 more prototypes followed, with tinkering done to improve rear visibility by adding twin rear view mirrors in blisters, one in each of 2 matching side panels of the 11-panel main canopy's openable section. The 3rd prototype got even more powerful, new pre-production DB603GO engines, which produced a whopping 1,900 horsepower each. The DO335 was found by test pilots to have good handling and great speed, over 470 miles per hour, that's 755 kilometers per hour in level flight, making it the fastest piston engine aircraft fielded by Germany during the war. It also had excellent climb rates and acceleration, outpacing Allied fighters in trials. Even with one engine out, it reached about 563 kilometers per hour or 350 miles per hour. General Field Marshal Erhard Milch described it himself as, open quotes, holding its own in speed and altitude with the P-38 and does not suffer from engine reliability issues, close quotes. The aircraft's name, Pfeil, or Arrow, came from the Reichsluftfahrtministerium, RLM's, that's Germany's Air Ministry. It was an evocative and powerful name for an aircraft that they clearly liked and wanted badly. 120 pre-production aircraft were to be manufactured by Dornier Werk Friedrichshafen and were to be completed as soon as possible, and contracts for over 2,000 335s in various models were due for delivery before March 1946 as well. One of the models was the DO335A12 Trainer, which had 2 seats for a student and instructor. This version was nicknamed the Ameisenbär, or Anteater, and yes, its long cylindrical nose makes the name fit. The urgency to build 335s was supercharged on the 23rd of May 1944 by none other than Hitler himself. As part of the Jägernotprogramm, or Emergency Fighter Program, DO335 production was given maximum priority, and some projects, such as the Heinkel HE-219 Uhu night fighter, were to be cancelled to free up engines for the 335. But there were delays due to a bombing raid that destroyed the tooling and forced Dornier to set up a whole new production line. Delivery finally commenced in January 1945. Yes, I know that sounds pretty late. And the United States Army overran the Oberpfaffenhofen factory not much after, in late April 1945. So only 11 DO-335A1 single-seat fighter bombers and 2 A-12 trainers were ever completed. Due to its very late arrival, there are almost no examples of interactions between the type and Allied aircraft. But in April 1945, French ace Pierre Closerman was leading a flight of 4 Hawker Tempests from No. 3 Squadron RAF over northern Germany when they ran into an unknown aircraft that might have been a DO-335. They fired on it, and it turned tail and ran, getting away. I guess at least demonstrating the Pfeil's impressive speed. There is a rumor that a 335 was involved in escorting Hannah Reich and General de Flieger Robert von Grimes' famous flight to Berlin-Gatow that I described in the Storch episode, but I'm not able to verify that. But, unfortunately for us, the 335 story is one of experimentation and development of a very cool-looking aircraft that just didn't arrive in time to see if its promise would be fulfilled. And there was so much promise. What is better than one 335? Yeah, 2 335s joined together. Yes, back in 1944, Dornier and Junkers worked together on the DO-335 Zwilling, which was also known as the Dornier DO-635. The idea was to take two DO-335 fuselages and join them together with a common center wing section. The 635 would be used for photo reconnaissance and would have two cameras mounted in the port fuselage for aerial photography. For night picture taking, provisions for 5 60-kilogram, that's 130-pound photo flash bombs was included. Wind tunnel testing was performed and a cockpit mock-up was completed, but that's as far as the production went. The P256 development of the Pfeil just makes me mad. The whole point of the 335, the whole concept the plane was built around, was that it was a twin-engine, pusher-puller, centerline thrust aircraft. Well, the P256 was intended to scrap the prop engines and hang two Henkel HES 011 turbojet engines under the wings, as on the ME-262. Yes, I will concede that the intended guns were impressive. The now engineless nose would be crammed with four 30mm Mk-109 cannon, which would be pretty devastating. But it never got beyond the conception stage, and so we don't even need to talk about it further. One version that did get to the prototype stage was a single-seat destroyer that had two additional Mk-103 cannon added to the wings and fittings for two 300-liter, that's 80 US gallons, drop tanks. Only 2 prototypes of those were completed. If you get some satisfaction of listening to the show, please consider supporting me over at World of Warbird's Patreon. It's only $5 per month. There are advantages to being a supporting patron of the podcast. You get the episodes a week earlier and bonus episodes. You also get an increased say on future content, like this episode was, and you're able to interact with me directly via the group chat or via the individual chats. But mainly, you'll have the satisfaction of helping to keep this podcast going. You can also toss me a tip via PayPal at WOWB17, or just give me a good review or share me with a friend. It all helps, and don't forget to tell me your name and where you're from so I can give you a proper shout out and thank you. DO-335 Werk Nummer 240102's story begins in 1945 at Dornier's Oberpfaffenhofen plant, where it was completed as part of the A0 evaluation series, and was given the tail number VGPH. Before it could fire its guns in anger, U.S. forces captured the facility. It and a sister ship was scooped up under Operation Lusty, the Allied program to seize advanced German technology. Remember, it's one of my favorite operational names and stands for Luftwaffe Secret Technology, with the LUSTY letters making the word lusty. She was briefly flown in Germany for evaluation, testing the tandem engines and handling before being carefully packed and shipped across the Atlantic, alongside such other exotic war prizes like the Arado AR-234 and Heinkel HE-219. VGPH went to the Navy for evaluation and was sent to the Test and Evaluation Center, Patuxent River Test Facility. U.S. engineers examined every detail: its top speed, climb, performance, and structural layout. After these tests, it was placed into long-term storage, where it remained largely forgotten for decades. Her sister 335 was tested in early 1946 at Freeman Field, Indiana, and her fate is unknown. VGPH underwent testing until 1948, and afterwards the plane was left to languish in outside storage at Naval Air Station Norfolk until 1961. But then she was donated to the Smithsonian's National Air Museum. In October 1974, VGPH went home to the Dornier plant in Oberpfaffenhofen, Germany, for a complete restoration. Fittingly by Dornier workers, many of whom had worked on her originally. They were mildly surprised that the explosives built into the aircraft to blow off the dorsal fin and rear propeller prior to pilot ejection were still installed. Oopsie! VGPH stayed in Germany until the late 1990s when she returned to the USA and can now be seen at the Stephen F. Udvar Hazy Center of the National Air and Space Museum. And is another excuse for me to get my butt down there at some point. So what happened to Dornier and his company after the war? The factories were dismantled or taken over by the Allies, and like other German aircraft companies, they were forbidden from designing or manufacturing aircraft under the Allied occupation directives. Dornier himself was interrogated and monitored, but not declared a war criminal or a leading Nazi or anything. He focused on civilian engineering projects and tried to keep the Dornier company alive by switching to other fields, such as producing household goods, mechanical engineering, and precision instruments. After 1950 and the easing of restrictions in West Germany, Dornier re-established as Dornier GmbH in Friedrichshafen, eventually becoming a major player in post-war German aerospace, expanding into jets, reconnaissance aircraft, and helicopters in collaboration with other European firms. Claude Dornier gradually stepped back from active management in the 1960s, handing over responsibilities to his sons and senior engineers, and he passed away on the 5th of December 1969 in Zug, Switzerland. While the original Dornier company no longer exists, after a series of mergers, it became part of Airbus, although its heritage lives on through multiple independent entities that still operate under the Dornier name, across aviation, medical tech, textiles, and even more. I promise that I will return to tell you more about Dornier warbirds in the future. Thank you to John Spooner, Tanner, and Jennifer from work for helping me with this episode. Thanks again to all who support the podcast through Patreon. I appreciate it more than you know. You can also check out some photos of what we've been talking about on the Patreon page. Those are available to all. While you're there, why not join Patreon? There's a free option to join, and if you can't do that, why not just leave me a good review? Until next time.